Good day, Circuit. My name is Jhon Corvera, and here is my video presentation for the final exam in problem solving. So, before I start, sir, I am very sorry for not able to complete answering those questions because I have an emergency in that day, sir. My father-in-law had multiple stroke last year, got again, and we're so worried about him. Um, I forgot that I have an exam on analytical chemistry on that day, and later on I realized that I have exam on that on analytical chemistry. Then when I saw the time, I think I have only 6 minutes or 5 minutes to answer the exam, and that's why, sir. So as you instructed, sir, we'll make a video on how we answer the problem solving on your final exam. So here it is, sir. So as we can see, pH is very low and we have a strong acid to start with. So let's go with HCl, this one HCl, which is ammonia, and you see our equivalence point here. So notice that this is below 7. So that means at the equivalence point, the solution is slightly acidic. And the reason for that is because we have a weak base. This one, weak base. Instead of strong one, that balancing the effects of the strong acid, and also if you write this equation for NH3 when it is placed in the water, it partially shades or ionized into NH4 plus. This one, NH4 plus. Plus, wait lang. Plus H2O. H2O. It is it partially shade, or this one will be ionized or ionizes into NH4 plus N plus OH minus. Since this doesn't go to the completion sum of completion, think some of this states that NH3 and some of this changes into NH4, and since NH3 is a weak base, its conjugate acid NH4 plus, it's a little stronger than the strength of NH3. So since this is a stronger acid, it's also causing the solutions to be acidic. So we've got the same general shape for a titration curve with a weak acid and a strong uh, base, but notice that the pH isn't as low, this one, as low as this one pH, as low as before in a weak base and a strong acid, because we're starting out with the weak acid, the pH isn't going as low. Plus, when we look at the equivalence point here, let's say just it is here, the pH is around higher than 7, right? This one. So that means it is going to be a little bit basic. Following the logic that we use for this titration curve, we have weak base, strong acid titration curve. We have weak base. We have a weak acid. I mean weak acids. We have a weak acid, so it means we must put a weak acid such as acetic acid. So HC2H 3O2 that partially associates to C2H3O2 and H plus ions. But remember, it's only partial of association. So because acidic acid is a weak acid, its conjugate base is stronger. So since C2H3O O2 O minus O2 minus more on strong base, it's going to accept protons and change back into this one, this HC2H3O2. So it's going to cause the pH at the equivalence point out that here you have what this called at the equivalence point higher than 7, this one. Also, I like to point out that here you have this area here, you have what is called the buffer region. So what's happening here? So here, when we titrate acid, the weak acid with the strong base, we have a conjugate base pair. So what's happening is, if we have a strong base such as this one, NaOH, it is going to steal the this H plus in out. It's going to steal the H plus from HC to H3O2. So what's going to create is a bunch of acidic acid, this one, and a bunch of C2H3O2, and that's going to create a buffer, because they're conjugate acid in sand bases.